This video was brought to you by Embedded System Solution, a company composed of like-minded electrical engineers, computer engineers, and computer scientists, and whose main goal is assisting our engineering customers, non-engineering customers, and technician level customers with their electrical and computer engineering level and technician level needs. Our customers range everywhere from engineering students to university professors, technicians to engineers, junior engineers to senior engineers. Please feel free to visit us at www.embeddedsystemsolution.com. Again, www.embeddedsystemsolution.com, or better yet, email us at support@embeddedsystemsolution.com. And like always, don't forget to subscribe to our channel and like. Okay, so we've basically reached the end of the road in terms of configuring SSH protocol, right? And so we're going to talk about how basically authenticate. So I've seen a lot of threads online, and in my opinion, this has the final say so in terms of what is the advantages. Well, there's two authentications, as we're going to be able to discuss. So let's get a hold of it. So anyways, so authenticate basically means that the computer that you're trying to log into, you have a username and a password, right? And so you must have previously access to this computer before you can authenticate. So authenticate basically means that the server looks at the list of the usernames and the accounts, basically usernames and passwords. You send over the username and the password, and it looks at the list and it says you're on the list. Think of like a bouncer, and it says congratulations, you could do remotely login. Here's your session. Here's the response, right? And in this case, authentication, we're talking about a switch. So the communication is one-to-one, right? There's no such thing as broadcasting like in an Ethernet hub, right? So authentication, if it's a unknown user, so in this case it's a known user. And by the way, if you don't know about users, we talk about the previous slide in terms of how to add users, delete users, modify users. So you must have a user account. If you don't know what we're talking about, check out the other video. So anyway, so another thing that I forgot to mention is that obviously to do remote login, to use SSH, you must have a user account on the client computer, and you also must have a user name and a user account on the server computer. So you must have accounts on both computers. So I forgot to mention that. So anyways, so in this case, if you don't have credentials, if you have no way to authenticate, then guess what? The computer's gonna reject your login attempt. So it's just no random people can log in. They have to be pre-approved people. You must have an account in there, right? And so when it comes to SSH authentications, there's two methods, and each method has a pro and a con, right? And I've seen threads where they try to discuss why is it that each one is better than the other one. And so I'm gonna talk about the pros and the cons of each method, right? And so as you can imagine, the username and password, you're literally entering your username and your password to authenticate, to basically gain access of the remote computer and be able to remotely log in. Whereas a public and private key, you're generating a public and a private key only during setup, so you can log into that computer. And I'm gonna show you how is it that the similarities and the differences, not similarities and differences, but the pros and the cons of each method, because I do believe that both methods are good. It's just that username and password, what gives it its bad rap is users that for password, they enter something simple. And I'm going to show you why that's the weakest link. Like as a password, let's suppose they put Alaska or Texas, or I don't know, something New York, New York. If you put that password, then it opens yours up for dictionary attacks. But what is actually dictionary attacks? What is that simple password? What is it that causes the issues, right? So let's check it out. So of course, first we're going to cover username and password, right? And so anyways, so here's the example. So we're talking about an Ethernet switch, right? So let's suppose you have access to this ping computer, to the client, the computer admin from the server computer. He goes in and he has credentials for that ping computer, the client computer, so he can remotely log in, right? He can log into that computer, but it turns out he wants remote login access to the server computer, right? And so with password and username, he's literally sending in plain text his username and his password. So I remember whenever I read this, then I'm like, then what's the difference from this to Telnet? Isn't Telnet plain text? let's keep going, right? And so he enters, let's suppose he wants to remotely log in. He enters his username, and that's not a problem. Usernames are supposed to be openly shared, especially in a single computer, in a Linux computer with multiple users. The username is not really supposed to be kept secret, but the password obviously is, right? And so this computer admin or this person, he enters this password, and it goes across the switch, across the network, and the server computer receives the password, right? And again, because it's a switch makes a connection from node to node, and it's different from a hub, right? The switch, there's no concept of broadcasting, and again, I'll show that right now, right? And so it's in plain text, so the computer looks at the list, it's called hash value, and it says, hey, I have this username, it has this password. Congratulations, you authenticated, you're good to go. Here's a shell. Now let's take it a step further, right? Now instead of a switch, let's use an Ethernet hub, right? And as we mentioned before in the telnet section, and again, let's suppose we have Mr. Bad Guy. He has like a small little embedded system with an Ethernet jack, and somehow he manages to connect his Ethernet computer and be storing everything that's being sent across the network, right? So he's a hacker, and this small little gizmo goes connected to the hub, and the computer admin has no idea, right? Let's suppose that, right? And so if username and password is sending the password in plain text, but this time you have an Ethernet hub, then just like the telnet example, can't the person, the baddie, Mr. Baddie, can't he see the username and password? It's in plain text. And the same thing, at the same token, then afterwards, the user sends his password. Well, again, if we're talking about an Ethernet hub, then theoretically speaking, because the Ethernet hub basically repeats it to every single port, whatever it receives from any port, it repeats it, sort of like a broadcast message. Then can't now it doesn't really matter that, the Mr. Bad Guy now has the username and password. It doesn't really matter that these other two nodes got it because they're ignoring it, but this guy's the bad guy. And if the information is being sent across the network in plain text, then there's no difference from SSH to telnet. Well, it is and it isn't sent in plain text. So it's actually being sent encrypted. Then why do we say that it's being sent in plain text? That doesn't make sense. How can it be encrypted but at the same time be plain text? So it's both at the same time. Well, it turns out that SSH has a decryption and encryption algorithm. What you can imagine, what you can visualize it as at the input of the Ethernet ports. Of course, it's symbolic, right? And so even though the password does get sent, so here we have a picture of it, it does send plain text, SSH encrypts the password, sends it across the network, and on the receiving node, it decrypts it. And so from the perspective of the application, the transmitting application and the receiving application, they only see it in plain text. They're none the wiser. They have no clue, because it's different levels, right? They have no clue that the information has just, nor do they care, that the information has just been, they think that it's being sent in plain text, but in reality, whenever it crossed the network, it was encrypted. So we say it's an encrypted channel. So that's why we say that the password and the username with SSH, whenever you're using password and username authentication, that's why we say that is plain text, but at the same time, it's encrypted. So it's, by the way, authentication and encryption are two separate things. By the time you're using username and password, so if you choose to use username password as authentication, then that username and password is always being sent. Every time you want to log in, it's always being sent. And by the time, whenever you're trying to log in, encryption always takes place. So the moment you do, I thought that encryption took place after you put the username and the password. So it's something interesting to think about that. Like I said, with me, I don't know if you have the same problem, but I was under the impression when I barely learned about SSH that the encryption takes place after you successfully put the username and the password. No, encryption takes place as soon as you start typing in your username and password. Encryption is already happening. The second phase is authentication. That hasn't happened yet. So that's something to keep in mind. So The answer is yes, the information is being sent in plain text, but no, it's not being sent in plain text. Like I said, it's perspective, right? It's so this guy, this bad guy, he basically, because it's being encrypted, he has no way to know what's being sent. So again, it is and it isn't. So my question is this. So what I was thinking when I was learning this, if the password is being encrypted, then what's the big fuss is about? There's no way a hacker can hack it if the password is being, you're seeing it right there. The hacker, he can't intercept it. He can intercept it, but he can't interpret it. So I'm like, well, it's the same thing. Well, it's not. Here's the issue whenever you have username and password authentication. It's not so much whenever you're transmitting the information, although there is a danger right there, but that's not really where the security risk lies. And so you're like, if the security risk lies right there, then let's just use username. After all, I think username and password is easier. Everybody's used to it, but it does have its negatives. So again, the information is sent encrypted, but the receiving application receives the password. And then, okay, so in terms of authentication, here's the next step that happens, right? So let's do the following step. That password is ran across a hash algorithm. Now you might ask yourself, what is a hash algorithm? Give me a second, right? So that output from the hash algorithm, it's a hash value, right? So we're going to talk a little bit more about this. Now, remember we were talking about the etc shadow file? If you don't know what that is, then go back to the previous video because we talk in depth about that file, right? And so in those series, we mentioned how every single user account on that server computer, his information is stored on that shadow file, his username and his password. And so whenever you try to do Authenticate, of course, the server is going to do a comparison to every single user and every single password right there. And if it finds a match, then it says